All right, let's jump right in. Have you ever stopped to think about how an app goes from just an idea on a developer's screen to running live on your phone? It's a pretty complex journey. But today, we're going to break down the modern superhighway that makes it all happen. DevOps.
This whole revolution really starts with one single infamous phrase. It works on my machine. If you're a developer, you've definitely said it. If you're in operations, you've heard it a million times. This one little sentence, it perfectly captures the core problem DevOps was born to solve. So, to get it, we've got to go back in time to the old way of doing things. It was a time defined by what everyone called the wall of confusion. And it's exactly what it sounds like, this huge imaginary wall separating the two most important teams in software. It was a system just filled with friction. See, on one side of the wall, you had the developers. Their whole job is about creating change, writing new code, adding features, trying to move as fast as possible. Their entire world is their own laptop where everything works just fine. But on the other side, you had the operations team, and their job was the exact opposite, to prevent change from breaking everything. They're the ones running the live servers, and their number one priority is stability. So they don't get a pager alert at 2 in the morning. You can already see the problem here, right? And this conflict, it created a total mess. Releasing new features was painfully slow, and when something inevitably broke, the blame game would start. Devs would say, well, it works on my machine, and ops would fire back, your code is unstable. Deployments were these risky, manual, all-hands-on-deck events, and the developers, they had basically zero feedback on how their code was actually doing out in the real world. It was just inefficient and super stressful for everybody.
So, how do you fix a problem like that? Well, the answer is DevOps. It's all about tearing down that wall. And the key thing to understand is that this isn't about buying a new tool or a new piece of software. It's a completely new mindset, a cultural shift designed to solve all those problems we just talked about by just getting rid of the barriers between the teams. At its heart, DevOps is really a culture of shared ownership. Instead of two separate warring teams, you have one unified team. And that one team is responsible for the entire life of an application, from the very first line of code all the way to running it in production. It really boils down to two main ideas: shared responsibility and automating absolutely everything you possibly can. Okay, so a new mindset is great, but how do you actually do it in the real world? That brings us to our first huge piece of the puzzle: packaging our apps with a tool called Docker. This was the technology that finally, once and for all, was designed to kill that "it works on my machine" problem.
So what is a Docker container? The best way to think about it is like a standardized shipping container, but for software. It's this neat little box that packages up your application's code. But not just the code. It includes everything it needs to run: all the libraries, all the tools, all the configuration files. And the result is this perfect, self-contained unit that runs exactly the same no matter where you put it, on a developer's laptop, a test server, or in the cloud. Problem solved. And what's really amazing is just how efficient these containers are, especially compared to the old way we did this with virtual machines. A VM had to include a whole copy of an operating system, which made it huge. We're talking gigabytes in size. And it would take minutes to start up. A Docker container, on the other hand, shares the host computer's operating system, making it incredibly lightweight, just megabytes, and it can start in seconds. That difference in speed and size is a total game changer. Okay, fantastic. Docker solves the problem for one container, but that just leads to the next bigger problem. What happens when your app isn't just one container, but hundreds, or even thousands of them? Now you've got a whole new level of complexity to deal with. This is where we need to talk about managing apps with Kubernetes. I mean, just think about it for a second. What happens when one of those 1,000 containers crashes at 2 in the morning? Who's restarting it? Or what if your app goes viral and traffic suddenly jumps by 10 times? How do you scale up instantly? And how in the world do you roll out an update to your app without taking the whole thing offline? Trying to do all that by hand is, well, it's impossible. You need an orchestrator. And that's exactly what container orchestration is. It's the brain of the operation. It's the system that automatically manages all of your containers for you. It handles scaling them up and down, it handles restarting them when they fail, which we call self-healing, and it makes sure they can all talk to each other. It brings order to the chaos. And when it comes to orchestration, the undisputed king is Kubernetes.
Honestly, the best analogy I've ever heard is to think of Kubernetes as the kitchen manager in a super busy restaurant. Your containers are all the individual chefs working hard on their dishes. Kubernetes is the manager, telling them exactly what to cook, calling in more chefs when the dinner rush hits, and making sure every single order gets out to the right table perfectly and on time.
All right, so we have the DevOps mindset, we have Docker to package our app, and we have Kubernetes to run it all at scale. Now for the final piece of the puzzle, the automated superhighway. This is where we connect everything together with something called CI/CD, creating this seamless automated flow from the developer's keyboard all the way to the end user. So this superhighway is called CI/CD. The CI part stands for continuous integration. That's just the practice of all the developers constantly merging their code changes together. And the CD stands for continuous deployment, which is the magic part. It means that every single change that passes all the automated tests is automatically deployed to users. It's the engine that powers this entire DevOps culture.
Here's how it works in practice. A developer pushes some new code to a place like GitHub. That single action kicks off a whole automated chain reaction. First, tons of automated tests run to make sure nothing broke. If all the tests pass, a brand new Docker image gets built. That new image is then stored in a central library, which we call a registry. And finally, the system tells Kubernetes, hey, go deploy this new version, and it rolls it out to users without any downtime. This whole thing can happen in just minutes, with 0 humans clicking buttons. And this whole superhighway runs on an incredible ecosystem of tools. You've got CI/CD engines like GitHub Actions that act as the brains of the pipeline. You have tools like Terraform that let you define your entire cloud setup, your servers, networks, everything as code, which makes it repeatable and super stable. And of course, this all runs on the massive cloud platforms like AWS, Azure, and GCP, where Kubernetes is basically the default way to run modern applications. And that is the ultimate takeaway here. When you bring together that DevOps culture with powerful tools like Docker, Kubernetes, and a full CI/CD pipeline, the result is simple. You deliver better software to your users, and you do it faster and more safely than was ever possible before. You get rid of the blame game, you remove all that manual risk, and you empower your teams to actually innovate. So we went from that wall of confusion to a fully automated superhighway. It's been a really incredible journey. But as we start looking to what's next, a new question is popping up. With the explosion of AI, could these automated pipelines start to manage, heal, and maybe even improve themselves? Is this superhighway about to get a self-driving upgrade? Now that is something to think about.